Okay, so hello everyone. This is the first time I am doing a video on any topic in physics. I hope all of you are safe in this situation that we are currently facing, and I hope that all of you are in the home quarantine as advised. Now, since we are talking about home quarantine, let me share a very small tale about this isolation and seclusion that is associated with the life of one of the famous scientists who is associated with these experiments and topics that we are going to deal with today. And the name of the scientist, I hope you might have guessed, is Sir Isaac Newton. Now, in the year 1666, at that time, Isaac Newton was a student who was 23-year-old, studying at the University of Cambridge. He was studying mathematics and physics, the natural philosophy as it was called at that time. During that time, the bubonic plague outbreak occurred in London. And as a result of that, just like the present scenario, all offices, all the workshops, the various schools, the universities, they had to be closed down, and he returned to his home, his ancestral home in Woolsthorpe. During that time, he spent there, just like all the other citizens of London, 18 months in seclusion. And it was during this time that the most wonderful discoveries about light, the motion of planets, mechanics, and gravity were made by him. 2 years previous to this, in 1664, he visited a fair. The fair was a very big fair in London. In that fair, he bought a small glass prism. He always wondered that why certain lights, if passed through glass or viewed through glass, appears colored at the edges, much like the 7 colors. He bought that prism and it lied somewhere at the corner of his room. He was burdened with his studies and never had the opportunity to investigate these questions, but during the seclusion, this genius, he devised the theory of the color, the theory of light, as to how white light is dispersed into the 7 components, the spectrum. He discovered the 3 Newton's laws of mechanics that you are familiar with, and as the story goes, the apple that fell on his head led to the discovery of gravity by him. And during that time, when he was dealing with these ideas of mechanics, these ideas of orbital motion, a lot of other scientists like Robert Hooke, Edmund Halley, the person after whom Halley's comet is named, were also investigating the motion of the planets, the motion of the stars, and also our everyday objects. And they all looked up to Newton for the help. And believe me or not, those 18 months were the most successful, the most fruitful period in his life. It made him the scientist that he was. So I hope you utilize this quarantine period of yours in a very good manner as well. You may not be a genius like him, but who knows, you might just find something hidden inside you which had been under pressure due to our daily routine till now. Now let us come to this chapter. This chapter is named, as you can see, spectrum. Now what are we going to study in this chapter? So in this chapter we will basically study about the nature of light, what are the components of light, and we will also deal with the scattering of light, which is responsible for the bluish color of the sky or the reddish color of the sun at sunset and sunrise. And we will learn a bit about the electromagnetic radiation, about the other forms of light apart from the visible light. We will know about the uses and applications and the wonderful stories of discovery behind them as well. So let us delve into this topic. So this experiment, as per the accounted history, was first performed by Isaac Newton. So what he did, in his room, the room in Woolsthorpe where he was during the isolation period, there was a window. And there was a small slit in the window that he created through which he allowed the natural white light from the sun to fall on that prism which he bought 2 years earlier at the fair. And he found that when white light falls on the prism, the end product is a band of colors, and coincidentally that band of colors has the same definite order of colors like the rainbow we see in the sky. The 7 colors you are familiar with, in short we call it Vibgya. They stand for violet, indigo, blue, green, yellow, orange and red. And violet is in the lower part of the order and red is in the upper part. So the spectrum starts from lower part to the upper part. Why does this happen? Well, you are already familiar with the ideas of refractive indices, and you know that the refractive index for any medium, in this case the glass with which the prism is made, is greater for violet light than for red light. Mu of V is greater than mu of R, and therefore the deviation that the violet light undergoes from the original path of the ray of light is greater for violet light as compared to red light. Violet light undergoes the most deviation and red light undergoes the least deviation in the visible spectrum. And because of that, violet light is in the lower part of the spectrum, whereas the red light is in the upper part of the spectrum. The wavelengths of violet and red light are roughly written here. Red corresponds to around 8000 angstroms and violet corresponds to around 4000 angstrom, but mind you, there is no such sharp distinctive boundary for the wavelengths of these lights. It roughly falls in this range. It can be plus minus 10 angstrom on either side. And from this experiment that Newton performed, he came to the conclusion that white light is polychromatic in nature. The word polychromatic means there are more than one color in white light. The word chroma is associated with color, and poly is anything more than one. You know about polygons and so on. So he came to the conclusion that these 7 colors are always present in the white light, just that it always does not undergo this phenomenon of dispersion, and as a result of that we don't get to see these 7 colors quite often. Now when Newton performed this experiment, his critics started saying that this white light does not contain the 7 colors, rather it is the prism which by some manner is producing the colors on its own. So Newton had to perform another experiment to show that the prism has got no role to play in these 7 colors. It simply ranges the colors as per their speeds. And for that purpose he performed this experiment. He passed white light onto a prism, assumed that the lower ray of light is violet light and the upper one is red light and the mean light is the green light. He allowed to fall that on a cardboard in which there was a slit small enough to pass the green light only, and that green light he made it fall on another prism, and the end product was green light alone. So this proved that a prism does not produce any colors of its own. So the green light that was incident on this prism was emerged from the prism. There was no new addition of colors. So it led to the conclusion that a prism produces no colors of its own. And even after this, he went on to perform another experiment which came to be known as the experimentum crucis, which stands for the crucial experiment. And what did he perform in that experiment? In that experiment, he allowed the white light to fall on one prism, which produced this band of colors, and then he made this band of colors incident on a second prism, and it was found that from the second prism the final emergent ray had the white light just like it had initially. That proved beyond doubt, it proved crucially that a prism does not produce any color of its own. Now here we will have to note 2 terms. The terms are spectrum, as it's written here, and dispersion. What is dispersion? Dispersion is this phenomenon of the splitting of white light into its constituent colors by the prism. The phenomenon of splitting of white light into its constituent colors by the prism is known as dispersion. And spectrum, it is the band of colors which is obtained when white light undergoes dispersion through a prism. And these are the two definitions which you should find in your book as well. Finally, we will deal with an idea, the idea of wavelength and color. So when we say that red light has 8000 angstrom wavelength and violet light has 4000 angstrom wavelength, the value which we are measuring in angstrom is a objective value of light. Wavelength is an objective characteristic of light. It remains the same everywhere. Red light will have 8000 angstrom value on Earth, on Mars, as well as in the Sun. But the color associated with light is subjective. Let us consider an example. Suppose we all know about people who are colorblind. The colorblind people often fail to distinguish between red and green colors. If you show them red color and green color, both of which has got different wavelengths, they might think that both the colors are the same because their eye cannot differentiate between the two colors. So for a colorblind person, for a certain subject, these two colors which have got different wavelengths appear to be the same to his eye, but their wavelengths are nonetheless different. Instead of a colorblind person, if you take a person who is pretty normal with his vision, he will distinguish between the two colors just fine. So that proves beyond doubt that wavelength is an objective property of light, and associated with wavelength is color, which is a subjective property of light. Because color not only depends on the wavelength, but it also depends upon the physiology of our eye. Thank you.